Constructed more than 85 years ago to protect low-lying areas of the Netherlands from flooding, the Afsluitdijk is a true wonder of engineering. Spanning 32 kilometres and holding back the Wadden Sea, the project was one of the largest engineering feats of its time and is credited with saving large parts of the country from catastrophic flooding in 1953. But while the Afsluitdijk has stood firm for almost a century, rising sea levels and stronger storms mean Dutch authorities are now investing $617 million to strengthen the structure so it can withstand a 1 in 10,000 year storm. Using 75,000 concrete blocks, constructing new drainage systems and being aided by the latest technology, this nation-saving seawall is getting a supersized upgrade. When works first started in 1927, the construction of the Afsluitdijk was one of the largest undertakings of its kind anywhere in the world, with more than 36 million cubic metres of material needed to span the 32-kilometre mouth of the Zuiderzee. Starting in 4 locations along the length of the dike, ships began dredging material and depositing it directly onto the sea floor until it breached the surface. Rocks were used to strengthen the dike, and it was raised to its final height with sand and clay before being topped with grass to hold the surface material together. Rising 7 metres above sea level and sitting 90 metres wide, the seawall enabled the construction of a causeway directly connecting North Holland with Friesland, drastically reducing travel time between the two provinces. While the site typically employed 4,000 to 5,000 workers each day, the end of the project saw 10,000 workers, 27 dredgers, 13 floating cranes and 132 barges work carefully timed shifts to feverishly close the wall at low tides. On the 28th of May 1932, the final gap in the dike was filled, separating the Netherlands from the Wadden Sea and creating one of Europe's largest lakes in the process. While many minor upgrades and improvements have been made to the dike in the years since, rising sea levels and an increase in the frequency and ferocity of storms has left it in need of reinforcement, and 2019 saw the start of a major strengthening project. While raising the height of the dike was considered, this would use more material and add significant cost to the project. Instead, engineers will strengthen the barrier by adding a layer of concrete reinforcing blocks along its length, resisting erosion and preventing breaches during rough storms. Each of these blocks will be microchipped to ease the process of tracing and maintaining them in the future. Though passive sluice gates were built into the original structure to discharge water from the lake twice a day during low tides, the difference in water level on either side of the dike at low tide is no longer enough for sufficient drainage. To ensure the lake doesn't become flooded by the rivers that feed into it, 2 of the largest pumping stations in Europe will be constructed alongside the sluice gates. The dike's locks will be expanded to improve the passage of boats, and the A7 causeway will be widened. When the seawall was first built, little concern was given to the environment or local habitats that the new structure would be dividing, and the dike caused a large drop in local fish populations. To correct this and encourage biodiversity, a new fish migration river will connect the 2 habitats. The sheer scale of this scheme means that over 500 architects, civil engineers and contractors are all collaborating throughout the design and pre-construction phases from different geographic locations. When the dike was first constructed, this simply wouldn't have been possible. Design coordination would have taken place in person, with engineers comparing paper drawings and updating hand-drawn information as changes were made. The contrast with today couldn't be more stark. To avoid mistakes which could cost time and money if discovered out on the seawall itself, the team are using Autodesk's BIM 360 model coordination platform. Uploading their design models into a shared environment online enabled the team to coordinate them and run automated clash detection, identifying any errors in the model before works commenced on site. This approach also gave the project team greater insight and understanding, improving quality and speeding up design iterations. The team used Autodesk's Assemble software to track, manage and visualize quantity changes between models, improving efficiency and cutting change management time in half. The use of a common location online to share and store design information ensures that engineers and contractors can always access and work from the latest information, further cutting the risk of errors occurring during construction. The clever reinforcement of this 1920s seawall, enabled by 2020s technology, is likely to prove a powerful example to other countries in the years ahead, as our planet grapples with a changing climate. Due to fully complete in 2023 and not require further major upgrade works until at least 2050, the seawall that saved a nation is likely to go on protecting it for decades to come. To learn more about how the Offshore Dyke project team was supported by Autodesk, click the link below. And if you enjoyed this video, subscribe to the B1M.